Hi everyone, this is Michelle from GCE Education Hub. Today we'll be going through properties of angles in circles. So let's go! Okay, students generally have difficulty remembering the angles properties of circles, and also sometimes they can't seem to find the properties. Alright, so we'll recap some of the properties before going through the questions. So first property is angle at the center is 2 times angle at circumference. So you can see that this is the angle at the center, and this will be double of the angle at the circumference. So this will be double of this. Alright, so you have 2 other variation, alright, where the circumference here is stretched all the way to the right side. Okay, it can also be on the left side. So you can see that this is also the angle in the center, and this is the angle at the circumference. So the angle here is also twice of the angle here. And the last variation is where you stretch this all the way downwards, which gives you this diagram. So you have to be very careful is that this is the angle at the center. Okay, and this will be the angle at the circumference. Alright, so this is the first property. The second property is angle in the same segment. Okay, you can see that one of the giveaway is that it looks like a kite. Alright, and you have to be very careful that all 4 sides must touch, okay, the circle. If you compare it with this diagram here, alright, you can see that the shape looks quite similar, but the only difference is that the center is here and it does not touch the side of the circle. So you can see that only 1 side, 2 side, 3 side touches the corner of the circle, whereas for this you have 1 side, 2 side, 3 side and 4 sides. Okay, the next property is angle in a semicircle. Alright, so number 1, alright, you have to identify the diameter, and when you extend this diameter up to the circle, alright, this will be 90 degree. Okay, and then you can see that there's another triangle inside the circle. Alright, this will also be 90 degree. Okay, and the last properties is the angle in opposite angles, or what we call angles in cyclic chord. Okay, is that opposite angle, alright, they will add up to 180 degree. Alright, vice versa, angle S and angle Q will add up to 180. Alright, also take note that all 4 sides of the quadrilateral must touch the side of the circle. Alright, so we're going to go through one example now. Alright, so we have a diagram. Okay, and you have ADB, which is 25. Okay, labeled here. Angle CBD, which is here. Alright, so the question is asking you to find ACB, which is this angle here. Alright, so we'll just draw it out, and CAD, which is this one here. So what I always advise my student to do is try to find all the angles out, alright, in the diagram before attending the question. So this will help you to see more of the properties. So you can see that we use angle in the same segment, so we can see a kite here. And you remember, angle in the same segment, this angle here will be equal to this angle here. So actually, your ACB is also equal to 25 degree. So this is angle in same segment. Alright, likewise, to find angle CAD, alright, we can see that you can also have another angle in the same segment. So angle CAD is also 40 degree. So it's the same reason. Alright, so we're going to look at the next example. So we have a diagram. Okay, O is the center, which passes through A, B, C and D. And SAT is tangent, alright? So this is a very important information. Alright, when they give you a tangent, alright, one of the property is that a tangent to the circle. Okay, if you draw to the radius, it will be 90 degrees. So actually, you can see that this is 90 degrees. Okay, so our aim is to try to find AOB, okay, which is this angle here, BAS, which is this angle here, and OAC, which is this angle here. Okay, so we'll proceed to find the angle. So number one, try to find all the angles out. So you can see that we have this angle at the circumference. So if you trace back, okay, can you see that this is actually angle at the center? So remember, angle at the center is 2 times angle at circumference. So we just have to take 56 degree times 2, which is equal to 112 degrees. So this is angle at the center is 2 times angle at circumference. Alright, so next, alright, we will try to find this angle. So how do we go about this is, if you can see that usually if you have a center, alright, to the circumference and another center to the circumference, it will usually give you a isosceles triangle because this length is equal to this length. So we have this angle as 112 from the previous question. We can try to find the angle BAO. Right, so we're going to take 180 degree minus 112. Okay, and we divide by 2 to find one of the angle. You get 28 degree. So this one is isosceles triangle. So noting that this is 28 degrees, alright, we are able to proceed to find BAS. So BAS is 90 degree minus 28 degree, okay, which gives you 62 degree. So this one, it follows this property, right? Tangent to circle. Alright, and the last angle, okay, is to find AOC. So our aim is to try to find this angle. Alright, so can we see that there is actually another isosceles triangle here? Okay, so we can see that, we can also use an angle in the same segment. So so can you see that you have this cut here? Alright, so we can see that this angle here is actually equal to this angle here. So angle ADB is actually equal to 56 degree. Okay, angle in same segment. Alright, and with that, angle AOD is also equal to 56, isosceles triangle. And lastly, to find OAC is simply 56 degree minus 26 degree, which gives you 30 degree.
So, this is how we solve angles in circles. If you find the content we are sharing useful, remember to like and subscribe. See you soon. Bye bye.